This is Chemistry Help. This is episode 2. We're going to be applying Le Chatelier's principle. Le Chatelier's principle is quite simple. It states that if a system at equilibrium is subject to some stress, the system will shift to minimize that stress. This stress can be a change in concentration, a change in temperature, or even a change in pressure when we're dealing with gases. Given this information, we can make a couple general rules to describe changes in equilibrium. So given this reaction, this system here, firstly, we know that an increase in concentration of substance will mean a shift away from that substance because it needs to be used up. And a decrease in concentration of substance will mean a shift towards it because we need to make more of it to refill it up. Temperature changes can be handled by treating heat like either a product or reactant, if it's exothermic or endothermic respectively, and applying Rule 1. And pressure will only affect gases, and higher pressure conditions favor less moles of gas. So let's practice this. Given the following system in equilibrium, this is the Aubrey process, explain the effect on equilibrium and the concentration of N2 given all of these changes. Firstly, an increase in the concentration of H2. We need to use up this additional reactant, and to do that, we have to take some of the N2 as well to form NH3. So overall, the system will shift to the right, and the concentration of N2 will decrease. Next up on our list is the decrease in the concentration of N2. A decreased concentration of N2 means we need to add more of it. We need to make more to fill that back up. So overall, it'll shift to the left and produce more N2. Next, an increase in pressure. To solve this, we should first balance the equation and also recognize the fact that all of these species are gases. From here on our left-hand side, we see that there's 4 moles of gas. And on our right-hand side, there's 2 moles of gas. So, since it's higher pressure, the 2 mole side, the less moles of gas, is going to be favored. So we're going to shift right, and the concentration of N2 will decrease. Alright, fourth and finally, a decrease in temperature. And the Haber process is exothermic, so keep that in mind. So what we can do is actually write here energy as a product, because it's exothermic. So energy is a product, and we know that a decrease in that product will mean we need to shift towards it. So we'll need to take some of the N2 and H2 to form energy, to form this exothermic reaction. So it'll shift right, and the concentration of N2 decreases. Alright, that's it. Thank you for watching. Leave a like, ring the bell, subscribe please, and if you have any questions or comments, leave them below. I'll try to get to them as soon as I can. Thank you for watching, and I'll see you next time.